Good afternoon, everyone. So thanks a good intro talk for Kubernetes that kind of gave you some insights what Kubernetes can do. So we're going to talk about a bit deeper things there. When you deploy Kubernetes, after that, what happens next, and how you can have multiple users using the same cluster, and it is secure enough that nobody kind of comes in and then just break your system and then do whatever he would like to do. So we'll kind of touch upon those points. Quick intro about myself. My name is Neependra, as you know, and I started this company called CloudYuga 3 years back. Before that, I worked for around 11 years in different companies, mostly with Red Hat. And in every 2 years, I tried to change my profile, and I had like support engineer, system, kernel development, performance engineering, and so on. I wrote a book on Docker Cookbook in 2015, and not sure whether how many of you have taken. There is a course on edX if you have done that. So there's a course on edX, Introduction to Kubernetes. I authored that for Linux Foundation or CNCF. It's the official course which they offer uh, to everybody to kind of onboard for Kubernetes. Um, and I also run the Docker Meetup group here for around 5 years now. And as CloudYuga, we offer trainings and consulting, and we are the only company in India who are certified Kubernetes training provider and training partner. Okay, with that, let's jump to the topic. So how many of you are kind of okay with this slide? That this is the architecture of Kubernetes. Just raise your hands. I can go a bit deep, it's not a problem. So if you're not familiar, I can just talk about briefly on these things and then we can continue from here. So this is the architecture of Kubernetes. I don't see much hands, so I'm just going to talk a bit on this. Um, we are the user here on the left, and then we talk to something called as API server. So we have the Kubernetes cluster, which is made of a few nodes, and one of the node, or there can be many master node as well, which we refer as the control plane. The control planes controls your what you can do in the cluster, and then there are these worker nodes which would actually run your workload, right? And we are the user. We can talk to this something called as API server. As you can see, the API server is the middle ground or the communication point to which everybody communicates. So we have the master nodes in which we have other components which we'll talk about, and the same API server talks to your worker nodes also. So the API server plays a very important role in doing anything in Kubernetes cluster, right? So we as a user can talk to the API server by the CLI, by the API, or by a dashboard. And then API server, which runs in the master node, communicates with some of the components of the Kubernetes cluster, or the master node there, which is one of the scheduler. Scheduler is the one which schedules your pod. Say, okay, this particular pod should run on node 1 or node 2. That is the job of scheduler. So when I say I want to create 3 copies of my application, my request will go to the API server. API will talk to the scheduler. Say, okay, I got this request. Now the scheduler would say, okay, you got see this pods to be created. Then we'll talk to the API server and saying that, okay, go and create pod 1 on node 2, pod 2 on whatever other nodes, right? The controller plane, the controller which was talked about, is the control loop. So there's the control loop which kind of makes sure that at any point of time, your current state is equal to desired state. So for example, you say that, okay, I want to have 3 copies of my application running. That is called desired state. And current maybe you're running 2, which means I have to create one more. And if desired count say comes down, if you scale down your application from 5 to 3, then 2 of the pods get killed and so on. And there's one more component here called key value store, which kind of stores your cluster state. So whatever the state of the cluster is part of this key value store. The key value store is the one which plays a very important role in the cluster, and this kind of think of a single point of failure, not the master node. Master node can go down, but your key value store should not go down at all. So that's why you have to make sure that you have a redundancy in the key value store. And the API server talk to the key value store. Uh, using the HTTP call and so on. On the worker nodes, you have this something called as kubelet, which runs on off your nodes. And the API server sends the command to the kubelet saying that run this container, run this pod for me. That's what the kubelet would do on all the nodes. By the way, kubelet also runs on the master node, so that's another topic. And then we have this kube proxy, which allows you the external access of the application to the um, to your application. So you deploy an application on your cluster, it would come through the API queue proxy within your application after that. So API server queue proxy becomes the external communication point for you. So it does not happen that your application access happens by the master node, it access by the queue proxy. So assume that it's all set up and everything is done. And I'm just going to talk about quickly about one of the tool which we have been kind of building right now. And I'll not go in the tool per se, but this would help us to do some of these hands-on which we'll do today. So this is a tool which we use for our training, which kind of building and kind of going to kind of launch in the KubeCon in Seattle. So let me just do a quick refresh here. Yeah, so what we'll do here is we're going to run in our demo, we're going to have our content on the left. And then as I'm going to show the demo, I could just copy paste and then just kind of have it much more easier. Right, so let's just go back and talk about our stuff. Okay, so now as a user, you kind of go and performs some operations. For example, you say, list me all of my pods that I have. Okay, create my new application. So while you're seeing the demo of creating a deployment or service, you would use a CLI or the API call, whatever it is, right? So for example, if I kind of go and show you a demo of that. So for example, here, what we have is, if I do, just a minute. If I say kubectl get nodes, or I do kubectl get pods. So I'm a user here, right? And I'm running a command to my cluster. And when I say, give me some details about what command I'm running here. So this kubectl is a CLI. This CLI is the one which would go and talk to the API server and give you the result back. So here, the CLI is kubectl, which talks to the API server and do whatever you would like to say. So kubectl is the one which, as a user, we are running, correct? Now, for the user to get access to the cluster, we need to provide some authentication that, okay, what you can come and do in the cluster, or how can you log into the cluster. So whenever you do something, to reach to the last objects, like pods or whatever, each process or each request goes through 3 stages. Authentication, which means, can I log into the cluster? For example, if you have a batch for the company, you can come inside the premises. But you cannot just go to any meeting room or whatever. You might not be authorized. So you could log into the cluster. Then the second step comes is authorization, what you can do in the cluster, right? And then once that happened, the last is that there's a last check, which is the request is valid, and there's certain checks which can be performed there. For example, if you have set the quota limit, you can say, in my Kubernetes cluster, this team dev cannot use more than 10 GB of RAM, or they cannot create more than 10 pods in my team namespace or whatever, right? So that check is being done in the admission control. So even if you are authenticated, authorized, and if there is not enough, or if there already been 10 pods has been created, you cannot create the 11th pod, correct? Because the last check has been failing. So authentication, authorization, and admission control, only when all of these 3 is being passed, then only you can access the object and perform any operations. Any questions so far? Okay, so let's take a talk about authentication now. So first of all, there is no first-class citizen like pod. So your users are not a first-class citizen. You cannot say kubectl create user, kubectl delete user. Nothing is like that is in Kubernetes. So Kubernetes always tries to offload the authentication part to something else like LDAP, Active Directory. So your Kubernetes does not have a first-class citizen of users. So what they have this normal user like us, right? So we are accessing the cluster. So we are the normal user here, and the service accounts are there. So for example, if your application somehow want to access the cluster objects, we would use service account. So you saw a demo of the dashboard application, right? The dashboard application in the last demo is just a simple, you can think of a Java code, a Python code, whatever it is, right? Now that application need to access the Kubernetes cluster API to get the access of all the objects. So for that kind of purpose, we would use a service account user. So we would create a service account user, and that user would be given to your application of the process. And that process can then perform operation behind the scene. So those are the special kind of users which you would use while communicating within the Kubernetes thing. For if one pod or one application which is deployed on Kubernetes want to communicate with the API server, that's when we want to use the service account object, right? Now, normal accounts, let's talk about them. So one simplistic thing you can do is you can write down for all of your users name and the email ID, whatever, the name and the password and the UID in a file. And that file can be given while starting your API server. So API server is the one we talked about here. So the API server is here. And while starting this thing, if I can pass the uh, just a string or just a file which contains these things, is going to just pick up those username and password is going to work. But as you can see, this is not scalable because you cannot write for all of your company's users just write like this. It's not a scalable solution, but there's a way of doing this thing. Other approach you can do is you could uh, kind of uh, offload your work to some third-party services. Like for example, whenever you download an application on your mobile, it says authenticate by Google, authenticate by Facebook, and so on. That can be enabled here as well. So you can say authenticate my user with Google Authenticator or GitHub Authentication. So that is also can be done here. So you can completely offload the authentication work to your those kind of OAuth services. The third one is X final certificate. This is nothing but what we generally comfortable with the public-private key, and that's what the combination we can use. And we're going to see a demo of this right away. So what happens is when you open, for example, if you take any example of your, and if you open any HTTPS website, what happens is you're going to, for example, you are building a website and you want it to be secured on the internet. So what you do is you generate the public-private key, give it to a CA, the CA certificate authority, who would verify certificate your kind of values and give you a certificate back, which you can use for the HTTPS website. A similar thing what going to happen here is we are going to use the CA, which is being kind of created at the time of installation of Kubernetes. So when you install Kubernetes, it kind of creates a CA of its own. And we are going to uh, do something like this here. So we are going to create a private key first, OpenSSL tool. With that, we would generate a certificate signing request. And that request, we would give it to the Kubernetes CA and say, verify this particular request and give the certificate file back to me, which I can use and communicate to the Kubernetes cluster, right? Before that, let me quickly go over this kubeconfig file. If you are aware, which is good. If not, it's very important part to understand in any of the scenarios. So for example, here is my kubeconfig file. This kubeconfig file contains three major sections there. One is called clusters. This says that which particular cluster you want to communicate. So for example, you have dev cluster, QA cluster, and ops cluster, so something like that, right? So in the kubeconfig file, you can list down like this. So this is my cluster, and this is its IP address, and so on. The API server IP address, and I'm going to refer this thing with the name of minikube. And then you have these users. So can have multiple clusters. You can have multiple users in the same file. So here the user is minikube again. And then once we have these multiple users, we connect a user to a cluster with the help of context, right? So here we have the context in which we are kind of creating a context called minikube, and in which we are connecting the minikube cluster to minikube user. So the too much of minikube may be confusing. So now if you look at this way here, so here you have user dev talk to the dev cluster, QA user talk to the QA cluster, and so on. So there can be multiple of these contexts, and only one of them can be active at any point of time. Now, what's going to happen in your environment of a developer? Your ops team is going to configure the cluster for them, and they are going to give the context or the config file which is specific to you only. So basically, as a user, you're going to not have a permission of the entire cluster. You could just have the kubeconfig file, which is just required for your team, your project, and so on, right? So what we'll do now is we're going to create a private key. We'll do a CSR request, and then we'll kind of come back again here. So let's go back to the tool here. So what I'm going to do now is I'm going to first create a directory. The directory name can be anything. Nothing to be is RBAC name. RBAC name just is a given there for a reference. And we'll create a new namespace called CloudYuga. So namespace, I think you know, right? Namespace is a way of partitioning your cluster into sub-clusters or sub-projects. So if I look at here, if I say kubectl get namespace, you would see there are 4 of them right now. 3 of them came by default, and 4th one we created right away. So we got the 4 namespace, or you can think of 4 teams here, or 4 projects. Right? That's all. If you are aware, that's good, but otherwise think about them. There are 4 teams which is being created here. Right? Now what I'm going to do now is I'm going to create a private key here. And as you can see, I got a private key called nkhare.key. And if I look at this file, this contains the typical private key, what we used to kind of very well know. So just go forward then. Next thing what I'm going to do is, so what we have done so far is we got our private key created with the help of OpenSSL tool. Next is we'll create a certificate signing request, which I can send to my CA for verification, right? So let me go ahead and do that. So here we are saying that I want to create a private the CSR request called nkhare, the CSR, and at the common name we are passing our username called nkhare, and the O means a group. So we are saying that this is for a user nkhare with the group called CloudYuga, right? Let me do that. So we got a CSR request. Okay, so we have the CSR request, which is saying that begin certificate request and so on. Now we have finished the 2-part step here. So we got a private key, we got a CSR request. Now we have to somehow convert this CSR request into the format which Kubernetes can understand, and then take it forward, right? So I'm going to do a base64 encoding of this data and put it into a file called csr.txt. So I've just taken this, whatever the data I had, because Kubernetes kind of understands this base64 encoding data. So I've done that part. So the next is, what I do is I create this file called signingrequest.yml. And in this file, I'm going to put this YAML file, which is going to kind of help you to create the CSR object which Kubernetes can understand. And then I'm going to get the content, what we have here. Sorry. So I'm going to copy the content, what we had just copied there, into the request section here. Where is this taking me? What's happening? Sorry. Let me just copy it manually. There's something issue here. Okay, this will not copy properly. Okay, so what I'll do just now is I'm going to get the request section here. And why this is, I'm really sorry about this. I should have tested it. Okay, Anyway, so what I'm going to do now is I'm going to just get my content out from here, and then this is going to be challenging. Okay. Hopefully this get copied as I expect. Sorry, it's something very. Okay, I'm just going to kind of go back to my. I want to use the tool. Sorry about that part. So I'm just going to. What I'm going to do now is I'm going to go to my direct to my machine there, and I'm going to work directly there. So let me just SSH to my cluster, and then I can show the demo from there directly. So let me just give me a minute. Sometimes the demo does not work as expected. So yeah, perfectly okay. Yes, I know. So now I'm again back to my master node, so it doesn't matter. I'm just good there. I'm just going to perform those steps one more time, and then I think we should be good to go there. So rather than doing it from here, I'm going to just fall back to my plan of using the Git repo directly. So just bear with me. I should be good to back on track in a minute. Uh, Yeah, so I think I just copy paste from here. Doesn't make much difference. Okay, so I'm just going to do the steps again. Uh, yeah, so what we did is this is the part where we left off, and we got its CSR data um, into the base64 encoding. And now what we'll just do is we're going to create a file, and in that file we are going to put down our stuff there. So we kind of go and say vim request.yml. Okay, and then hopefully it doesn't make a difference there. And I'm going to copy the content, whatever I have the base64 encoding, and then I'm going to go to the request section there, and I'm going to put down that value here. Right, so I have now created a YAML file. This name is different, shouldn't be a problem. So I'm going to say kubectl apply -f request. This works, yeah. So what we got is now we kind of pushed our CSR request to the Kubernetes format. So the Kubernetes now understand this CSR request. And if I do kubectl get CSR, you would see that my request in the pending state. So what would have happened is, other than the admin user, somebody else would have created this request. And that request would be given to my Kubernetes master or the admin user, who is going to verify this request. So what we will do is we will say kubectl again, and we'll say certificate approve. Sorry, approve encourage CSR. Right? So what happened is now our request got approved by the Kubernetes CA. And if we now see, our request has been approved and issued. So let's go back to a bit on the slide. So we got a private key, we got the request, we put it into the Kubernetes format, and the Kubernetes CA has verified it. So now what we got back is the certificate, the certificate and the private key in our this folder, right? So in the current folder, what we have, the private key and the certificate. No, not, we don't have a certificate now. It has been approved. So what we'll do now is we are going to say kubectl get CSR, And then we're going to say kubectl get CSR, encourage CSR into with the YO YAML output. So I'll say minus O YAML, and this would spit out me in the YAML output, right? So what we have now is we have the certificate in this base64 encoded format. I want to take this data out and put into a text file, which we kind of do. So let me just get that command there quickly. So I'm just going to read that output again as we did saw the previous thing. And I'm going to get this data into a CRT file. So now what I have is in the current folder, I have the private key along with the certificate data, right? So now we can now log into the cluster. So what we do what we have to do next is we have to somehow create this kind of mapping, because we have the user separately. So currently our config file just contains the admin user. We are going to now create an Anchor user and ask the Anchor user talk to the cluster which we have. Make sense? So let's go ahead and do that. So I'm going to trigger down a few more commands. And this command is going to create the user. So if I open the kubeconfig file again, which is being used every time I access the cluster, and this kubeconfig file, I would have a new user called Encurry, which is being towards the end. With that command we have added. So we have now added a new user. And then what we're going to add a new context. In that context, we'll say our Encurry user would talk to the same cluster which we already have, right? So we are going to the next step there. We are going to now create a new context called Encurry context. And that Encurry user can talk to the cluster Kubernetes in the namespace of CloudYuga, right? So let me run another command, and this command creates that mapping. So now what happened is we got this mapping now. We got the mapping of saying that Encurry user can talk to the Kubernetes cluster, right? And the way I can check it up, I could say kubectl config get context. So as you can see now, I've got two contexts. So earlier I had only one context, which is currently being active. The star sign means it's an active context. So if you have multiple contexts, you have to make one of them active. So our active one is the Kubernetes admin at Kubernetes. Now, let me go and change the context to Encurry context. So I'll say kubectl config use context, and the context name is Encurry context, right? So now the star sign would have moved from that to our Encurry user. Now let's try to list the pods. And what we get is a forbidden. Any guess why? Why get the forbidden? Sorry? Yeah, so we have just finished only the first part. So like for example, you can say anybody can come to my cluster, but what happened is we just finished the first part, authentication part. So even if you enabled authentication by Google Auth or whatever, there's only first part we have done right now is authentication. So you can come in there, but next what, you are not given any permission by default, right? So the next thing comes is authorization. What a user can do in my cluster is authorization, right? So there's like, can I user do a requested action? There's authorization there, and there are different modules are there, which you can kind of look at here. So generally people might just kind of for testing purpose, they might use always allow, always deny, which is as the name suggests. The node authorization module is being used by worker node to talk to the master node and so on. There's an attribute based, which is you can send some attributes of what user can do and so on, which is not very used right now. So people are mostly using right now with role-based access control, which we'll see a demo now. And there are these webhooks based. It's similar to that. If somebody comes for me for authorization, I'll offer to something else. But we'll see a demo of role-based access control. And in that, we need to understand what kind of an operations when we do with the objects. So for example, we could do get, delete, list operations to our objects of pods and so on, right? So create, get, delete, and so on the operations we do, right? Now, what we do is in Kubernetes, we create something called as a role and a cluster role. The role is bound to a given namespace. So as you can see on the left side, we have this role which is bound to a CloudYuga namespace. And in that CloudYuga namespace, what you can do is you can perform these operations. So let's talk about API group, which we'll hear more today. So what you do here is, what you look at here, this is then under kind of an hierarchy of the way Kubernetes puts all of these objects under certain hierarchy. So if you kind of go and run this command, kubectl API versions, you would see these API endpoint which comes by default. And the way we extended the help of CRD, which we talked about briefly and we'll talk about later today as well. So as you can see here is, there's something called as apps, and at the bottom we have these V1. So if you kind of go back to the slide here, so this slash API always referred as core API group. So if somebody says just codes, which is a core API group, and somebody says APIs apps, somebody says apps V1, basically they're referring to slash APIs slash apps and so on. And all of our objects kind of get into there. So for example, a pod object is under core API group, while a deployment object in the apps group and there. And you can kind of add these objects as you kind of go there. So what we are saying here is, this particular role called deployment manager is applicable only for the API groups called core API group and my APIs slash apps. Only there you can kind of work on. And in that you can work on deployments, replicas, and pods. So you can work on only of these three objects, not more than that. And what you can do there, you can do get, list, watch, and delete, and so on. But these are the operations what you can do there. No delete is there. There's no delete. And then the second kind of role, you can create a cluster role, which is applicable cluster wide. So here, if you look at, there is nothing called the namespace here, which means if you're creating a role called deployment manager, it would give you access to the entire cluster namespace and so on. Okay, and then the next thing what we do is we bind those rules to our subjects or the users. In our case, our user is Khare. We are going to bind that user to a given role, which we'll see in a bit. So let's go ahead and create a file called role.yml. And I just need to copy the content from there. It should have been automated there, but yeah, something is screwed up with the software. Okay, so here we are creating the thing here. So we'll say kubectl apply -f role.yml. So why we get this error? Yeah, so if you look at what is our context right now is, our context is Kubernetes or the Khare context, which first of all doesn't have any permission. We are asking it to create a role. It's going to fail. So what we should do is, we should first become the admin user back again, and then we can create the role, correct? So we'll say again, kubectl context, the use context, and we'll become the admin again. Sorry, what did I do? Sorry, I should say config use context, not context. Right? And with that, now again I became the admin there, and now I could create the role. So as you can see that unless you don't have a permission, you can't do things, right? So what people are going to give you in your ops team is they're going to create the cluster and they're going to give you config file so that you can work only in your namespace. You can't just go and do everything everywhere, right? Let me apply this thing. And now I got deployment manager role created. Let me see kubectl get roles. I don't see any role. Why? I don't see any roles. Why? Any guess? Sorry? Yes, wrong namespace, correct? So we created, this is what? A role is applicable to a given namespace. A cluster role you can see there, but not the role. So you need to go to a specific namespace. So I'll say get roles and my role username or the namespace is CloudYuga. So here I would see my role. Make sense? So a role is bound to a given namespace. So your project would bound to have a specific role for yourself, right? So we got a role. Next is we're doing the role bindings. And as mentioned earlier, in role binding, we are going to attach a user, a subject to a role. So here we are creating a role binding, and in which we are saying we are giving a role deployment manager, which we created in the last step, to the user Khare. And because this user is bound to a cloud namespace, we are saying a namespace here as well. So we are saying this, we are creating a deployment manager binding, role binding, which would connect or which would kind of give the deployment manager role to my Khare user. So let's go ahead and do that. So role b.yml. And let me again copy the content from the Git repo. Right, so which is good. So let me just go and apply this role. I'm going to see the file. If you see, so it's the same thing which we saw there. So kubectl apply -f. So we got a new role binding created, and with that, I could now use the context of Khare context, and let's try to list the pods now, right? So either I can again use the use context command, or I could say kubectl context. On the runtime, I'm saying that use the context of Khare context, right? And say get pods. And now we don't, what is it? Kubectl context, unknown, okay, hyphen context, sorry. Right? Because there are no pods, we can't see the pods. That's why. Otherwise, if there has been pods, we could see the pods, right? Let's try to create a deployment and see what happens, right? So I could say kubectl run, which runs the command using which I could create the deployment on the fly. Let's give a name for the deployment, and let's say nginx, the image name. If I'm correct, that's how we should do, right? Okay, I cannot create extension. Okay, extension is not given. So okay, because this particular deployment comes under the extension, that's why we cannot do it. Anyway, doesn't matter. I'm going to get a pod.yaml file, and which we can use and so on. So let me quickly get a deployment file. I think, yeah, or let me just do it right away, which I kind of give you one more example. So I'm going to say, I'm going to write a pod.yaml file, and I can just give you a quick intro how you can write an YAML definition. So for example, I want to create a pod. That pod sits under the V1 API version, right? So for example, if I kind of go back to the slide, and if I say, I want to create a pod, where is that slide? Yeah. So where is my pod object, which sits under the API v1 and v1 API version, whatever that API v1 pods, right? So what I'm going to do is I'm going to write a pod definition pod.yaml file where I'll say API version is equal to v1 because that's where my pod object resides. I say kind is my pod object, right? I give a name of this thing with the call metadata. Name of my pod would be, let's say, my pod. And in Kubernetes, you always have something called desired state. For that, we write something called spec. So whenever you want to have a desired state, you would say, this name would go here. So I'm going to say a spec. I still have around 2 minutes left. Let me just quickly go over. So spec says what you want to kind of do in the desired state of these things. This is the pod. I'm going to have a container section here. Containers. And in this containers, I think, maybe I'm missing something. Yeah. So I'm going to have a name of my container, say myc. And I'm going to say use an image called whatever, nginx alpine. I just wrote it like YAML file like this, so maybe it might be wrong, but let's see. So I'm saying that go and create a pod for me, and with this particular one container in that pod. So let's just go ahead and try to create a pod. So there's some issue with the YAML file. Can anybody, where do I need the space with the containers? That's all right? Yeah, I think that's all. Hopefully. Yeah, so you got my pod created now, right? So your pod works now, right? Let's try to list services now. Same context. Let's try to list a service. Can I do that? No, because in our role, we haven't said that you cannot work on the service objects. You can work only on deployment, pods, and some other object, right? You cannot work on the service object. So you know that an admin can control what you can do in the cluster. Make sense? Or similarly, you can write a cluster role in which I'm just going to skip the demo for that round. So there is no namespace given here, which means you can do in all of the namespaces, and then you can define the same cluster role bindings. The kind becomes cluster role bindings, and you can say encourage user can now look at in any namespace what kind of pause deployment you're running. Okay, so we are good with time now, right? So any questions? Correct. Yes, encourage we are using for doing the all this pod creation, all that. Yes, yes. Earlier we were the admins, but now after that we not be the admin because we changed the context on the runtime, right? Any other questions?
So I have a question. Basically, it regards to the container management in the Cloud Foundry runtime. So we have Kubernetes, which orchestrates containers.
Okay.
And in Cloud Foundry runtime, we have something called Diego.
Yes.
I don't know much about it, but it's similar to Kubernetes. So what is the difference between these two container managements, orchestrations? Rather, I see Kubernetes much more advanced. It has
No,
more
so I think
capabilities.
Yes, as far as my knowledge goes, I'm limited knowledge there with Pivotal there. So Pivotal kind of use their Diego and there's some other word they use to kind of manage the gardens, right? The garden container, right? So if you recall that Diego creates a garden container and so on. So kind of they have been kind of trying to use their own setup with this thing, but now pushes towards Kubernetes. So even the Pivotal team kind of going towards using the Kubernetes as the underlying engine itself. So now Pivotal comes with two versions now. One is the typical what they have, the older version, where they kind of manage it with the Diego and the other containers, garden containers, and they have a new version which is coming up with the Kubernetes as underlying platform. So they are going to go kind of eventually kind of go away with their own management of the Diego and those things. So they're going to have a Bosch. Bosch is the orchestrator there. Bosch is going to kind of use the Kubernetes manifest or Kubernetes. It will set up Kubernetes cluster for you, and it'll work from there. So to answer the questions, both can do the same stuff, but if you look at the overall ecosystem, the way things are going, Kubernetes has won the war and it has taken things to the next level there. So I think Pivotal is going to be, I'm not going to talk about that, but it's not going to be used so far. So yeah, anyway, they're kind of moving towards Kubernetes as default one. So I think you know that VMware bought Haptio. There's a company called Haptio, which was founded by two of the Kubernetes original founders, and it's been bought by VMware recently, and the completely shift is going towards Kubernetes there.
Okay, so in the future is going to be the Kubernetes, which
Yes.
is going to be in the
Next
platform
10 years,
side as well.
at least I can say.
Okay, thanks.
Any more questions? Okay, we are good then.